Dear students, in previous class we were discussing about the completeness property of R. So we are mainly discussing the boundedness of a set. Means the set is bounded only when which is bounded both above and below. So a set is said to be bounded above if it has an upper bound, and is bounded below then it has a lower bound. Okay. Then consider a set of all x of all in R such that x less than 5. Consider set A equals set of all x of all in R such that x less than 5. X less than 5 means so consider the real line. This is the real line. If it is 5, then so this is the given set. Means x less than 5 means every element in this system is less than 5. Therefore, what is 5? Then 5 is an upper bound. It has an upper bound 5. What is the lower bound? What's the definition of a lower bound? If set A x of all in R, or S is a non-empty subset of R, then S has a lower bound if there exists a real number W such that W less than or equals yes. But we cannot find out such an element in this set. Therefore, this A has no lower bound. A has no lower bound. Means it has an upper bound, means it is bounded above, but it is not bounded below, means it is not. It has no lower bound, so it is not bounded below. Therefore, the set A is unbounded. Why? Because we know that a set is bounded if it is both bounded above and below. But here we cannot find out a lower bound, means the set is not bounded below, therefore the set is not bounded, means A is unbounded. Consider another set. B equals set of all x of all in R such that x greater than 5. X greater than 5. So when x greater than 5, what is the lower bound? X greater than 5 means the 5 is the least, or 5, yes, the 5 is a lower bound. Here there is a lower bound which is 5. But there is no upper bounds. So B has no upper bound means B has no upper bound means B is not bounded above. Therefore B is again unbounded. So a set which is not bounded, then the set is said to be an unbounded set. Okay. Now consider another set. Suppose A equals set 1, 2, 3, 4, etc. up to 10. Means the set of natural numbers up to 10. Then we know that 10 is an upper bound, and every number greater than 10 is also an upper bound. Here 10 is an upper bound, and every number greater than 10 is an upper bound. We also know that a bounded set has, or a bounded above set has infinitely many upper bounds. Also, it has infinitely many lower bounds. So, here 10 is an upper bound. Why? If you choose any real number, then if you choose any real number, then 10 or greater than 10, then all the elements in this set should be less than or equals 10 itself. So 10 is an upper bound. Okay. And any number greater than 10 is also an upper bound. Means here 10 is the least upper bound. 10 is the least upper bound. Okay. 10 is the least upper bound. Then this least upper bound is known as supremum. It is known as supremum of A. Okay. Similarly, here 1 is a lower bound. 1 is a lower bound. How many lower bounds are there? There are infinitely many lower bounds. Okay. There are infinitely many lower bounds. So minus 1, sorry, all the numbers less than 1 is also a lower bound. How many lower bounds are there? Infinitely many lower bounds. But which is the largest lower bound here? 1 is the largest lower bound. Why? Because 1 is a lower bound and infinitely many numbers less than 1 act as the lower bounds of the given set. All the numbers less than 1. So 1 is the largest lower bound or greatest lower bound. Here 1 is the greatest lower bound. Greatest lower bound, and this greatest lower bound is said to be infimum of A. So these are two important definitions. What is supremum and infimum? Supremum means the least upper bound and infimum means the greatest lower bound. Here 10 is the supremum and 1 is the infimum. Means in case of a finite set, we can conclude this result in this way. If for a finite set, the largest element is the supremum and the least element is the infimum. Means if you consider another set, B equals set 1, 1 by 2, 1 by 3, 1 by 4, etc. 1 by 70. So this is again a finite set. This is again a finite set. Then which is the largest element here? The largest element, 1 is the largest element and 1 by 70 be the least element. So this largest element is the least supremum and least element is the infimum. Okay. So how to define generally this supremum and infimum? So far consider a set. Let S be a non-empty subset of R. Then an element U found in R is said to be the supremum of S. An element U found in R is said to be supremum of S or least upper bound of S. Supremum of S or least upper bound of S if no other element less than U is an upper bound. U is the least upper bound means no other element act as the or no other element less than U is being an upper bound. Means U is an upper bound of S, then there are two conditions. One is U is an upper bound. U being a supremum of S for any non-empty subset S of R only when U is an upper bound of S and no number less than U is an upper bound of S. Means if V is an upper bound of S, then then U less than or equals V. Means no number U is act as a supremum or least upper bound means no number less than U is an upper bound. Okay. Thus this U is said to be supremum. Similarly, you can define the infimum. If S is a non-empty subset of R, then consider yes, it is suppose A. Let A be the infimum. A be the infimum of S. Means A be the greatest lower bound of S. Only when there is no number greater than A is a lower bound. A is the greatest lower bound. So if B be another lower bound, then no number greater than A is a lower bound. If there exists another lower bound B, then surely this B less than or equals A. So this is the supremum and the infimum. Supremum means least upper bound. So a number is a least upper bound only when there exists no other number less than that one is an upper bound. Which being an infimum if no number greater than that one is a lower bound. Okay, so this is a definitions of infimum and supremum. Supremum and infimum, these are two important points. Supremum means least upper bound, infimum means greatest lower bound. Okay. Now, we say that for a set, for a finite set, there are infinitely, or set has if a set has an upper bound, if a set has an upper bound, then it has infinitely many upper bounds. If a set has lower bounds, there are infinitely many lower bounds. We already see it. But what about the infimum and supremum? That's an interesting question. We know that Listen, suppose A equals etc. 1, 2, 3, etc. up to 10. Which is the supremum here? Least upper bound. 10 is the supremum. Here 10 is the supremum. Why? Because for a finite set, the largest element is the supremum. Here 10 is the supremum of A. Okay, 10 is the supremum of A. Why? What is supremum? Means if you choose, means 10 is a real number. So every element in this A should less than or equals 10. Okay, so 10 is the supremum. We also know that 11 is also a supremum. Okay, 11 is also a supremum. 10.5 is a supremum. Not supremum. 11 is also an upper bound. 10 here, 10 is the supremum of A, or 10 is an upper bound of A. Moreover, 10 is an upper bound of A. 10.5 is also an upper bound of A. 11 is an upper bound of A. How many upper bounds? Infinitely many upper bounds. So, but 10 is the least upper bound. Means there exists only one least upper bound. Similarly, 1 is the greatest lower bound. Every number less than 1 is a lower bound, and 1 is also a lower bound. Therefore, there is only 1. So 1 is the greatest lower bound. Means the supremum and the infimum are unique. Supremum, and there is only one supremum and only one infimum. Supremum and infimum are unique. Okay. Supremum and infimum are unique. How to prove this one? So we can prove in this way. Let S be a non-empty subset of R. S be a non-empty subset of R. Let U1, U2, if possible, U1 and U2 are supreme. U1 and U2 are, if possible, U1 and U2 are supremum of S. For the uniqueness, we have to show that this U1 equals U2. If possible, U1 and U2 are supremum of S, then since U1 is a supremum, U1 is a supremum of S, that implies this U1 strictly less than U2. Okay, if U1 and U2 are supremum of S, then by trichotomy, there are three cases, either U1 equals U2, or U1 less than U2, or U1 greater than U2. Then we have to roll out these two conditions. Or in order to prove the uniqueness, the usual technique is, if possible, there exist two supremums, let it be U1 and U2. Now we have to show that U1 equals U2. Okay. Since U1 is a supremum of S, what is U1? U1 be a supremum of S, and what is also U2 be a supremum of S. It is given U1 and U2 are supremum of S. Now, in order to prove U1 equals U2, we have to roll out these two conditions, U1 less than U2 and U1 greater than U2. Suppose U1 less than U2, if possible U1 less than U2. What happens here? U1 less than U2 means U2 is not supreme. U1 greater than U2, U1 less than U2 means U2 is not a supremum. That's a contradiction. Why? We know that what is a supremum? If U1 is a supremum, then there is no number or less than U1 is a supremum. U2 is a supremum, then there is no number less than U2 is an upper bound. That's our definition. Okay. If U1 less than U2, then what is U1? U1 is a supremum. What is U2? U2 is a supremum. We have to show U1 equals U2. If possible, U1 less than U2, what happens there? U1 less than U2 means U2 is not a supremum. That's a contradiction. If U2 less than U1, that means U1 is not a supremum. Okay, by definition of supremum. That's again a contradiction. So U1 less than U2 and U2 less than U1 are rolled out here. Thus, only possibility U1 equals U2. Thus, supremum is unique. Similarly, you can show that infimum is also unique. Why? Suppose V1 and V2 are infimums. V1 and V2 are infimum of S. Then, either this by trichotomy, either V1 equals V2, or V1 greater than V2, or V1 less than V2. In order to prove V1 equals V2, we have to rule out these two conditions. If V1 less than V2, what happens if V1 greater than V2? That implies V1 greater than V2. That means V2 is not a lower bound, so infimum, that's a contradiction. If V2 greater than V1, that means V1 is not a greatest, as V1 greater than V2, then it is not a infimum, that's again a contradiction. So the other two conditions are ruled out, thus V1 equals V2, hence infimum is also unique. So we conclude here in this way, means if a set is bounded above, then it has many upper bounds. If a set is bounded below, then it has many lower bounds. But the least upper bound is known as supremum and the greatest lower bound is known as infimum. And we also conclude that the infimum and supremum are unique. If a set is bounded, then it has a supremum. If a set is bounded, then it has only one infimum. Okay, so these are the two important concepts, that is supremum and the infimum. Okay, thank you.